While American construction crews debate regulations and timeline extensions, something extraordinary is happening on the other side of the planet. China isn't just building faster than the West. They're building in ways that seem to violate the laws of physics itself. A 57-story skyscraper erected in 19 days. Entire dams constructed by artificial intelligence without a single human operator. Bridges that hang over 2,000-foot canyons, assembled by robots guided by satellites. And here's what makes this truly shocking. These aren't concepts or proposals. Every single project you're about to discover is either already complete or under construction right now. The question isn't whether China is ahead anymore. The question is whether the rest of the world can ever catch up. Let me show you what I mean. Back in 2015, a construction company made a claim so absurd that engineers worldwide dismissed it as impossible. They said they would build a complete skyscraper in less than 3 weeks. Not the foundation, not the framework, the entire building. Most experts laughed it off as propaganda until the time-lapse footage started circulating. Mini Sky City rose 670 feet into the Changsha skyline in exactly 19 days. 57 stories, 200 apartments, office space. Structural integrity tested and verified. How? The entire structure was modular, prefabricated in sections off-site, then assembled on location like precision-engineered Lego blocks. While conventional skyscrapers take years to complete, this tower reached full height faster than most buildings get past groundwork. But here's the part that should terrify Western construction firms. The same company immediately announced their next project, a 220-story tower using the identical method. That's not incremental improvement. That's a complete reimagining of what's possible, and they're not stopping with buildings. Deep in the Tibetan Plateau, construction has begun on something that sounds like pure science fiction. The Yonk Dam will stand 590 feet tall when completed. On its own, that's impressive but not unprecedented. What makes this project absolutely revolutionary is how it's being built. The entire dam, every structural component, every support beam, is being 3D printed by autonomous robotic systems. Massive printers layer concrete with millimeter precision, working 24 hours a day without fatigue or error. But it gets even more incredible. Every piece of equipment on site, the trucks, the bulldozers, the cranes, operates without human drivers. Artificial intelligence coordinates the entire construction process, calculating optimal workflows, predicting maintenance needs, and adjusting to weather conditions in real time. Zero accidents, zero delays, zero human error. Engineers estimate completion in under 2 years, a timeline that would be impossible using conventional methods. If this succeeds, and every indication suggests it will, the implications are staggering. It means China has cracked the code for fully automated mega construction. Now, if you're finding this as fascinating as I am, and you want to stay updated on more breakthrough developments that are reshaping our world, hit that subscribe button right now. We're pushing toward 10,000 subscribers, and your support helps us bring you these eye-opening stories. Also, drop a comment below telling me which of these projects shocked you the most. I read every single one, and your perspectives always add incredible value to these discussions. Let's keep going, because what you've seen so far is just the beginning. In September 2025, China opened what is now officially the world's highest bridge. The Huijiang Grand Canyon Bridge in Guizhou Province soars 2,051 feet above the Beipan River, more than twice the height of America's tallest bridge. Building something at this altitude posed challenges unlike any other. Traditional cranes couldn't operate effectively. The forces involved were massive. The margin for error was non-existent. Chinese engineers solved this with the largest cable crane system ever constructed, capable of lifting and positioning steel components weighing over 21,000 tons with satellite-guided precision. But this isn't just about raw engineering power. The bridge itself is embedded with smart monitoring cables, a neural network that constantly analyzes structural stress in real time, predicting maintenance needs before problems develop. When American engineers saw the completion timeline, many refused to believe it was possible. A Western project of this scale typically requires 5 to 10 years from groundbreaking to completion. China finished it in roughly 3 years. Then there's something even more audacious, though it remains in the planning stages. The Phoenix Towers proposed for Wuhan represent architectural ambition on a scale that makes Dubai's skyline look conservative. Two interconnected towers designed to rise 3,300 feet, with the taller structure potentially becoming the second highest building on Earth. But height is merely the foundation of this vision. These towers are designed as vertical power plants. The entire exterior would be covered in solar panels, while internal systems would harvest wind energy, thermal differentials, hydrogen fuel cells, and biomass conversion. They wouldn't just consume electricity. They would generate it, potentially powering thousands of homes. The taller tower would feature the world's highest sky garden, a floating forest above the clouds. The entire complex would rise from an artificial island in a lake. While construction has not yet begun, the detailed engineering plans demonstrate China's willingness to pursue projects that other nations consider impossible. Whether or not this specific vision materializes, it reveals something crucial about Chinese infrastructure philosophy. Nothing is too ambitious to attempt. Now, if you think 3D printing is limited to small objects or prototypes, China is about to shatter that assumption completely. In a stunning demonstration of what this technology can achieve at scale, they constructed an entire public park in Shenzhen, spanning nearly 60,000 square feet using nothing but massive 3D printing machines. Every element, benches, sculptures, retaining walls, flower beds, was printed from concrete in flowing, wave-like designs that seemed to merge seamlessly into organic shapes. Traditional construction would have taken over a year. This was completed in 2.5 months at a fraction of the cost. Every curve perfectly formed, every element mathematically precise. But they didn't stop there. In Shanghai, engineers used the same technology to create the world's longest 3D printed bridge, stretching 86 feet across a waterway. Two robotic arms worked continuously for 450 hours, printing 44 hollow concrete sections for the main span and 68 curved pieces for the handrails. The result looks more like modern art than infrastructure, with elegant wave patterns that complement the surrounding landscape. What's remarkable isn't just that they proved 3D printing works at this scale. It's that they're already moving to even larger applications, like that dam in Tibet. Here's a challenge that seems simple until you actually attempt it. What do you do when a century-old historic building sits exactly where you need to construct a modern subway station? Most cities would face an agonizing choice between preservation and progress. China found a third option that sounds impossible. They moved the entire building. The Huyanli Shikumen complex, weighing 7,500 tons, needed to be relocated so engineers could build underground shopping centers, parking facilities, and subway connections beneath it. The solution involved 432 robotic hydraulic jacks that carefully lifted the structure, then shifted it forward in synchronized steps, essentially making the building walk to a new location. Once the underground construction was complete, they moved it back to the original spot, perfectly intact. Zero structural damage, every architectural detail preserved. This happened in 2025, not decades ago. It's the kind of engineering feat that demonstrates not just technical capability, but a completely different mindset about what's negotiable in construction. Want to see ambition on an almost unbelievable scale? The Dalian Jinjiang Airport isn't being built on existing land. They're creating an artificial island in the ocean, specifically to construct what will become the world's largest offshore airport. Work began in 2011, essentially building new territory from the sea itself. then erecting a complete international airport on top of it. When it opens in 2026, it will handle millions of passengers annually, all on land that didn't exist 15 years ago. This isn't just infrastructure development. It's geographical engineering, the literal reshaping of coastlines to accommodate human needs. And finally, something that seems small but represents a revolutionary shift in construction methodology: inflatable domes. Construction sites are environmental nightmares, spewing dust, noise, and pollution into surrounding neighborhoods. Chinese engineers developed a brilliantly simple solution. They seal entire construction sites under massive air-filled structures that trap dust and harmful particles while muffling machinery noise. Advanced filtration systems clean the air before it's released, dramatically reducing the environmental impact. It's not flashy, it's not record-breaking, but it shows a level of thoughtfulness about construction's broader impact that's largely absent in Western building practices. So here's what all of this adds up to. While American infrastructure crumbles and Congress debates spending bills that go nowhere, China has fundamentally reimagined construction itself. They're not just building faster. They're building smarter with technologies that most of the world is still treating as experimental: artificial intelligence, three-dimensional printing, modular assembly, satellite-guided precision, autonomous machinery. These aren't future concepts in China. They're current methodology. The real question facing the rest of the world isn't whether China is ahead. That's obvious. The question is whether this gap can ever be closed, or if we're watching the emergence of capabilities that fundamentally reshape global competition for the next century. Because right now, looking at what they've already accomplished, the answer seems pretty clear.